Okay, so as I assume many of you know, a couple of years back, a new ISO, International Standards Organization, standardization effort was initiated to create an international standard top-level ontology. And the result is ISO IEC 21838, which will be a multi-part standard. And part 2 of this standard is basic formal ontology. In this tutorial, I'm going to describe part 1, and then I will describe how part 2 satisfies the requirements laid down in part 1. And I will then focus on the new parts of BFO, which have been created in tandem with work on this ISO standard. And Alan Ruttenberg is responsible for many of those new parts. It may be that he will wake up in time to present his slides at 11:30, which is 5:30 in Buffalo. If he doesn't wake up, I will present his slides. And then in the final section, part 4, Michael Gruninger will present the work on potential further parts of ISO 21838, including a part devoted to Dolce and a part devoted to something called Tupper, which he will explain in detail. So this is actually a standard of the Joint Technical Committee number 1 of ISO and the International Electrotechnical Commission. So IEC is concerned, for example, with things like plugs and sockets, so that when we travel we can fit our plugs into the sockets that we expect them to fit into. And so we see BFO as a connector to enable people to plug in their domain ontologies in such a way that they can still talk to each other. Now, 2 parts of ISO 21838 have already been released as draft international standards, DIS, which is the final phase before they become full international standards. And the final vote to move to this final phase is in October, so it's within the next few days, in fact. The ISO 21838-1 and -2 documents will then be released some weeks later than that, after a series of further formal steps taken by ISO. Assuming that the vote is positive, but I am confident that the vote will be positive because all the previous votes have been positive, which doesn't say that they were unanimous, but they were overwhelmingly positive. Okay, so we're going to start with part 1. Part 1 is about the requirements for being a top-level ontology. Now, one obvious requirement would be that you have to be an ontology in order to be a top-level ontology. And so we defined ontology in part 1 in the following way. So the goal that we were trying to address here was to create definitions which would be acceptable to, broadly speaking, the OWL or the semantic web or the RDF community on the one hand, and also to various communities of domain ontology developers in areas such as biology and biomedicine. So there is a huge constituency of ontologists who are working on the gene ontology and on the ontologies which have developed out of the gene ontology, and they have developed a terminology of their own, which has been used also by other people, and which is somewhat different from the terminology used in OWL. For instance, in the OBO, Open Biomedical Ontologies world, they call relations, relations, which sounds like a good choice of word. In the OWL world, relations are called object properties, which is not necessarily quite such a good choice of word. So these definitions here are, in a sense, compromises, but we hope that they are clarificatory compromises. Nowhere in the standard, nowhere in parts 1 and 2 anyway, is the word concept used. And I did not just use the word concept, I mentioned it. So, instead we use the word term, and we use the word expression. So, ontologies are linguistic artifacts. They're made of terms and expressions. Some of these expressions are relational expressions, which means that they represent relations in some sense. The terms in general represent classes, if you're working in the OWL framework, and types or universals if you're working in a framework like BFO. Now, we think, and we specified this in the definition, that every ontology should have natural language definitions. And therefore, an ontology is a collection of terms and relational expressions which includes natural language definitions. We also insist that every ontology should have a formal representation. And so we say, in fact, we say that it should have one or more formal representations. As we will see, for BFO, there are an OWL representation and a first-order logic representation. All right, now an ontology is a top-level ontology if it's domain neutral. In other words, if it applies to all domains. And in order to specify that requirement, we have to define what it means to be a domain. And these definitions are to be understood in the ISO context. So ISO is designed to help human beings. It's not designed to help computers. And so these definitions are the kinds of definitions that you find in a dictionary. They're not the kinds of definitions that you would find in an ontology. So this part one is not an ontology of ontologies, and these definitions are not to be understood as contributions to a formalization. So a domain is just an area that people might be interested in. It's as simple and as problematic as that. And then a domain ontology is an ontology whose terms represent classes or types in a corresponding domain. Then we define a category, which is a very general class or type. And I think we all in this room understand what that means. It's going to be a class or type represented by a term like object or process. And then a top-level ontology, finally, we can define. It's an ontology that is created to represent categories shared across practically all domains. So this is not rocket science, but it's hard. It was very hard to get those definitions in the right shape to serve the many purposes which this standard is going to serve. Okay, so now the requirements. First of all, the ontology should include no domain ontology content. Sumo is not a candidate for being a top-level ontology because it's full of bits and pieces of biology and physics and so forth. Not all of those bits and pieces are acceptable to biologists or physicists, which is one of the reasons why a top-level ontology is needed, because then you're not saying anything about physics or biology, and therefore you're not risking being incompatible with what physicists or biologists want to find in their ontology. And then secondly, even though it doesn't have any domain ontology content, it is still required to cover everything in the universe, just at a highly general, which is to say domain neutral level. And so the way we specified how this requirement is to be validated was as follows. We created this list, and we said every top-level ontology has to be such that it can address, in whatever terminology you like, that may mean tag, or it may mean annotate, or it may mean axiomatize, representations of data about all of these different kinds of entities and distinctions. So it has to have a way of representing spatial and temporal relations. It has to have a way of representing what is actual versus what is possible. That way could mean an explicit category of possible entities in the ontology, Or it could mean that there is some logical way in which possibility can be defined in terms of the top-level ontology, even though possible entities themselves are not recognized by the ontology. So there has to be some way in which the top-level ontology can be used to support the representation or management of data pertaining to all of these different kinds of dimensions. Now, BFO does not have a representation for God, for instance. I don't think Dolce has such a representation, although who knows. BFO doesn't say anything about religion, of course, and neither does Dolce. But supposing that we had religious data, how would BFO or Dolce deal with religious data? Well, they would deal with it in the same way they would deal with data about chess or mathematics. Namely, we have data about religious practices, we have data about religious adherence, about church buildings, and we can deal with those data perfectly well. We can't deal with God necessarily, but we can deal with religion as a social, cultural phenomenon. That's how BFO addresses that particular challenge. All right. Now the next requirement is that the top-level ontology has to have a textual artifact, it has to have an OWL axiomatization, and it has to have a common logic axiomatization. Common logic is itself an ISO standard, and it was very important that we reuse existing relevant ISO standard content. The textual artifact is the document ISO 21838-2 for BFO. That document does not contain any formal content. It only contains natural language text. The formal content will be deposited in the ISO public maintenance portal, and it will be free for download. And I will include in a few minutes a link to that content. So the formal content is already free and publicly available. Anyone can see it. I'm going to be talking about it in the rest of this tutorial. The textual content is still under ISO copyright. The assumption is that once it's published by ISO, it will be freely available, both for part 1 and for part 2, and for any further parts, potentially. Although ISO politics about copyright is not something that I'm a specialist in. But the formal content you can already see, and if you find mistakes, we would be tragically hurt, but also very happy, because then we can fix the mistakes before the final publication. All right, so the textual artifact includes a list of all the terms in the ontology. This is a requirement for being a top-level ontology. So in the case of BFO, we have to provide a list of all the terms in BFO and of all the relational expressions, and we have to identify, this is a requirement in part 1, all the terms which are primitives, because you can't define all terms, certainly not at this level of generality. And then it also has to include natural language definitions. Now, in the BFO part 2, there are 2 sets of definitions. The first set is a small list of definitions of general terms which were not included in part 1, which belong to the meta level. So that's not important here. It's a very short list. The main content is a very long list of definitions of all the BFO terms and of all the BFO relational expressions. And we'll see why that is a long list. Even though there are only 34 terms in BFO, it's still a long list for reasons which you will become clear in a minute. It also contains various comments to the definitions, which are also an ISO requirement, and also examples for every single one of the terms and relational expressions. Now, it's a requirement in part 1 that there should be provided an OWL axiomatization. It's a requirement that it should be in OWL 2 with the direct semantics, as long as that is the recommended syntax for W3C, but W3C may say, no, you should use OWL3, and then the standard would still apply. And then the signature of that OWL axiomatization should be a subset of the list of terms and relations specified in the textual artifact. Ideally, it should be identical to that list. We have not. Well, it will become clear why that is an issue in due course. And then the common logic axiomatization should be such that the signature is indeed identical with the signature in the textual artifact. Moreover, it's easy to prove an OWL axiomatization consistent, at least relative to the reasoners that we have available. It's very, very, very difficult to prove that a very large first-order logic axiomatization is consistent. The BFO first-order logic axiomatization has 300 axioms, and prover 9, which I think is the most commonly used automatic theorem prover, will not give you a proof of consistency without a lot of manual effort, but prover 9 breaks when you get beyond somewhere like 100 axioms. And so to prove consistency for a 300 axiom large axiomatization was a work of absolutely amazing logical effort by a human being called Alan Rottenberg. And we'll see the content of that axiomatization in due course. Thirdly, we require in part 1 that the OWL axiomatization in the BFO part and the Dolce part, if there is one, and the Tupper part and so forth, that the BFO OWL axiomatization has to be derivable from the BFO common logic axiomatization logically. Now that too is quite a tricky constraint to realize. It's certainly not trivial to prove that an OWL artifact can be derived from a first-order logic artifact when we're dealing with artifacts of this size and scope. All right. Now, how does common logic help? Why do we need a common logic axiomatization? Well, I think that's fairly clear for anybody who's built an ontology with regard to some complex domain. So the infectious disease ontology has a really complicated set of definitions which were worked out arduously with infectious disease specialists. Very few of the definitions can be captured exactly in OWL. This one can. But this one, which is a relatively simple one by IDO standards, involves a 5-place relation. And this one, which is also a relatively simple term, involves an 8-place relation. And it involves the use of time systematically in ways that in OWL you can't even begin to capture. And so to capture the infectious disease ontology in OWL is practically impossible. To capture this ontology using common logic is possible. The issue, of course, is what do you do with the common logic once you've captured your ontology? And that's why the development of automatic theorem provers to assist in using common logic ontologies for reasoning purposes is needed to be brought much further than it has already been brought. And we know from working with people who are interested in this sort of content that one of the consequences of the development of this standard will indeed be a big push towards further investment in automatic theorem provers for common logic and therefore also for first order logic. All right, and now something else which is provided in both part 1 and part 2 is the documentation of how you use top-level ontologies. And the primary use is as a hub for a modular approach to ontology development where each domain ontology is built by extending downwards from the top-level ontology. And this is the hub of the OBO biological and biomedical ontologies is the first example of a hub and spokes ontology which has been developed systematically from a top-level ontology. There are other examples now, but that was the first one that was developed systematically in that way. And the rules for doing it are, in the case of BFO, are documented already in this paper. And the detailed rules for doing it with BFO are documented in part 2, which I'm going to move to now. But first, are there any questions about part 1? Everybody completely happy? Yes?
Just the slide on the methodology to use the top level as a hub.
This one?
Yeah. There are absolutely no relation directly between domain modules.
This diagram does not exclude that. Some relations will automatically flow. Yeah. So that I don't like spaghetti. There will be easily derivable cross-domain links, but there'll also be specifically asserted cross-domain links by the domain ontology developers. So the OBO Foundry is full of cross-domain links, because if you have a gene ontology sentence which involves reference to some chemical, for instance, then there will be a link to the chemistry ontology. Yep. Yes.
So you said it's a list of terms, basically, with comments and examples. But this is
so the ISO format is very, very strict. And I don't think I can remember that. I think there are 5 parts, but I'm not guaranteeing that I'm remembering correctly. So the first part is the introduction, in which you say what it's about, basically, why you need the standard. The second part is a list of references, and those references are references that you reuse in your text, and which ideally are exclusively other ISO standards. We were allowed, with special permission, to refer in that list also to W3C standards, but you can't refer to papers in journals in this authoritative reference list. Then there is the normative content. Normative means you have to follow it, and that starts with a list of terms and their definitions in the ISO mode. And then there is a statement of the standard itself, which in the BFO case includes primarily a list of the terms and relational expressions used in BFO and of their definitions. Then there is another list of references, which can be slightly longer. In our case, it's not really longer. And then finally, so all of that is the normative content. Finally, there are called appendices. And these appendices are much less constrained. They can also be normative, but they can also be informative. And an example of an informative appendix to part 1 is a study of the use of the word ontology in other ISO standards, which is insightful because it shows that there is no single use, and that none of the definitions provided of ontology by ISO are anything like as precise as the one that we provide. So they are of the form collection of concepts, or equally unhelpful, I would say. Yep.
That's the first part, which is valid for all.
Yeah.
Fixes the method to derive the old version from this common logic version.
Yes, that specifies that the OWL version has to be derivable from the common logic version.
There's many ways of deriving it.
Oh, that's how you derive it has to be by some accepted logical means, but we don't specify exactly how it should be done. You yourself, if you're writing a new part, would have to specify how you did it. There's some detail about that will follow in the in part 3.
Or several or many versions.
Oh yes, so that's allowed. It says at least 2. So if you really want to include all 329 versions of Dolce Ultralight in part 3, you could do that if you wanted.
Yes, I mean, if you take the common logic as standard
Yes.
basis,
Yeah.
then you can derive many different old versions because
Yeah. So good. This is important, and I will talk a little bit about this later, but I'll address the point here for safety's sake. So the common logic is much more expressive than the OWL. Therefore, there are many OWL representations which will be conformant. Now, as it happens, the ISO wanted a normative version in both common logic and in OWL. So you have to pick one normative version. But in the BFO part, we defined at great length what it means for an ontology to be BFO conformant. And there we specified that an ontology is BFO conformant, that is to say conformant to ISO 21838-2, if it is logically derivable from the common logic axiomatization. So even though we're specifying one normative OWL representation of OWL, we welcome other representations of BFO in OWL, because now for the first time we have a way of proving whether they're mutually consistent, and they always will be because they're derivable from a larger axiomatization which has been proven consistent. So, all right, so now I'll move to part 2. So part 2 is BFO, and it's available at this link if you want to spend 58 Swiss francs. So here the contents are as follows, and the terminology will be clear enough now. I can go through this quite quickly. So we have the textual artifact, we have a proof that it is domain neutral and absolutely general, as I explained, and we have this is the link where you can find the formal part, which is already there. It's not yet on the ISO portal, but it is freely available, and it almost certainly will not change. And then we have a long guide to how you use the content of these two standards to create BFO conformant ontology content, both OWL representations of BFO along the lines we just discussed, and also domain ontologies which would be conformant to BFO. So there are different ways of doing that, which we recommend. And they are documented at length in the standard, in the textual part of the standard. Anyone who is interested in this kind of content can email me, and I will provide you what you need. All right, so this is what the formal content looks like. So there are 5 bins with names which are to some degree intuitive, and I'll go through each of them in turn. So the OWL bin includes an OWL formalization in RDF XML format, another formalization in a functional syntax using URIs, and then a third version in a labeled functional syntax, which is easier for human beings to read. And now, for each of these 3, we provide 2 versions. One version corresponds to BFO2, which has a very, very small set of relational expressions. The other version has a gigantically large set of what we call temporalized relations, and which I will go through in detail later on in this tutorial. In the bin called model, we have the models used to prove consistency, the model used to prove consistency of our CL formalization in 3 versions. And we have the axiomatization itself, which is in the CL bin, and then in the PDF bin, we have a set of PDF files which capture the common logic axiomatization using standard first-order predicate logic syntax with upside-down E's and A's, so the kind of syntax that is easy for human beings to read. Now, this is BFO-ISO, just the ISA hierarchy. And this is BFO2. So the colors are slightly different, but there is actually very little difference between those two. I'll tell you what the differences are. And I'm going to go, or Alan will go through some more detailed differences later on in the tutorial, but the main ones are as follows. We deprecate process profile. So I like process profile. Many people are going to continue to use process profile. We will continue to support process profile, but not as part of BFO. It will be part of some other ontology. And that's for complicated reasons, which I can address, if you wish, in the questions. We have two new classes or terms. One is temporal instant and one is temporal interval, both of which are children of temporal region. And the reason for this will become clear in a minute, but a zero-dimensional temporal region need not be a single point. It might be 6 separated points. And similarly, a one-dimensional temporal region might not be a temporal interval. It might be 2 temporal intervals with a gap. So we now have cleaned up the question of continuity of time regions. Then we rename zero-dimensional continuant fiat boundary, and we call it fiat point, and similarly for fiat line and fiat surface. All right, so they are really the only changes to the vocabulary, if you like, of BFO2. We will create a small widget which will allow people who have developed ontologies using BFO2 already to convert them to BFO-ISO conformance more or less automatically. So the changes are relatively minimal at that level. Now there are some other changes which we go through in more detail in the final section where Alan will either speak or speak through me. So there are some bug fixes. There is the formalization, the consistency proof, and then we have the basis for multiple different OWL versions which we just talked about. And now a little bit about the rollout strategy. So we anticipate the publication of parts 1 and 2 of the ISO standard in the spring, early spring, a bit earlier than that if we're lucky. Simultaneously, we will release a revised version of the BFO2 spec, which will conform to the existing spec, except we'll probably remove a lot of the philosophy which is there at the moment, because who needs philosophy? We will also update all the definitions. The changes are typically just changes which amount to clarification rather than correction, but there are occasions where we did make mistakes. And then also there are many more examples of use which we provided only a smattering of in the BFO2 spec. And that will be released for critical review. People will be able to review it, and then we will publish some more definitive version shortly thereafter. We will then work with the community of BFO2 users to try and get them all to move from BFO2 to BFO-ISO, and good luck with that. But we think we can manage in certain communities who have control over the sub-communities that they work with. And of course there are going to be some people who will start doing ontology with the BFO precisely because of the BFO-ISO standard, and that's already happening, as we will see in a minute. And then, as I say, we'll create software tools which will enable updates to be performed semi-automatically, and various other software tools which will be associated with the use of common logic for ontology development. And there is already some considerable impact in various corners. So there is an ISO standard in preparation called ISO 29303, which is on interoperability, which has been fashioned on the basis of ISO 21838. So it's a kind of descendant now of 21838. There will soon be a new, now I'm not sure whether it will be a new standard or a new revision of an ISO CEN standard for materials testing, which I think will be a materials testing ontology. I'm not exactly sure. I will know in 2 weeks what that will be, because they are taking 2 days out of my life in order to rebuild or recreate their materials testing standard. Then the Joint Artificial Intelligence Center in Washington is creating an ISO standard for AI, which will have some content from 21838. And there are large efforts underway now to create military suites of ontologies and intelligence ontologies using ISO 21838. And then there is a link here. I'm going to give you the link to these slides, and then you can click on the link to this page where a list of some 20 engineering ontologies using BFO can be found. Now, many of them were created just in recent months. They don't actually use the BFO ISO standard yet, but they exist in part because the BFO ISO standard is coming down the pipe. And then there is the Industrial Ontologies Foundry, which is an initiative of various representatives from industry and from the National Institute of Standards and Technology to create ontologies to support digital manufacturing and related efforts. And that too will be influenced by the existence of the BFO ISO standard. But there are already papers which have been created by this group, including a paper on maintenance ontology, a paper on manufacturing ontologies which form a modular suite, and a paper on physics-based simulation ontology, and as I say, a dozen or so other papers of this along the same lines. And then there is not only this textbook, there is also this textbook, which will be published, I understand, also early next year in some language which I don't recognize. But all right. Now, BFO is, I am the first to recognize, not by any means perfect. So there are areas in BFO which are strong, I believe, but there are other areas where we still have a lot of work to do. One area which is already underway is to expand the use and the understanding of the BFO theory of sites. So the point of introducing site was that we were doing biology, and biology is full of organisms, and organisms live in places like rabbit holes or buildings or habitats of one kind or another, and so we needed a word for those places of the sort in which organisms can live, and so we introduced the word site for that purpose. But we still need to have a much clearer understanding of the distinction between a site and a spatial region. And so we are working on that in tandem with developing, for instance, a theory of protein sites, which are places, as it were, on the surface of proteins where other proteins or other molecules can lock onto the protein. We are working on creating a BFO-based ontology of units of measure. Now, this is very difficult. There are things called joules per second squared. Now, I don't think that BFO can deal with joules per second squared. I don't think anybody can deal with per second squared entities anyway. What is a second squared? What is the ratio of something with a second squared? I don't think those things are ontologically easy to understand. And so our ontology of units of measure is going to involve a large degree of creative use of information artifacts. It will only be a certain, maybe the basic units of the IS standard which will be captured using BFO, and the rest will be captured using IAO. But we're not sure, but we are going to work on doing that in a systematic way. Another gap in BFO is that we do not have anything like systems in BFO. We have objects, we have object aggregates, we have fiat object parts. All of those are material entities. I think that systems, in the best sense of the word system, are also material entities, and so maybe we need a fourth kind of material entity in BFO. BFO never claimed to be complete, so this is not an error, it's a gap, and I would like to fill that gap, and I'm still not sure how to do it. And then the most important problem, which people complain about ad nauseam, is that BFO does not have a way of representing the qualities of processes. So, for instance, if your heart is beating, and I'm sure it is because you're all awake, then it's beating at a certain rate. And that means that the beating of your heart has something like a quality, which is the rate at which it is beating. And BFO only recognizes qualities of continuants. It does not recognize qualities of occurrence. Now, finally, we have a solution to this problem, which is being exemplified, instantiated, or implemented by the OBO Foundry community. And it goes like this. So BFO has qualities which are specifically dependent continuants which depend on continuants. So temperature is an example of a quality. And process qualities, so-called, would stand to occurrence in something like the way in which qualities in BFO stand to continuants. And the reason why we have the problem in the OBO world anyway is because the OBO quality ontology, which is called PATO, the A stands for attribute, I think. Attribute, anyway. The OBO people liked QUI acronyms in those days. So they just had a large bundle of qualities which does not differentiate in the way that BFO requires. Now, PATO wants to be BFO conformant because PATO wants to be an OBO Foundry ontology, and being BFO conformant is a requirement of being an OBO Foundry ontology, and so PATO is called upon to clean up its quality ontology. And so it looks like a trick, but it's not in fact a trick. The first step is something like this, that all the PATO process qualities are renamed process characteristics. And then all the remaining qualities in PATO will be BFO qualities, as was required. And characteristic now is just an abbreviation. It's a defined class, as we call it. So what it means to say, for instance, that John is running at 3 miles per minute at a certain time is that John has a certain quality, namely the quality of running at 3 miles per minute at that time. Now, it's also the case that John is a participant in a running process at that time, and we can infer from that, using this defined class, that the running process has this characteristic of having the rate of 3 miles per minute at that time. So it's a very simple trick, but it works in order to make PATO conformant to BFO. And well, this is just a generalized version of what I just said. All right, now I would like to leave more time for the Alan part, so I'm going to break here for another question session. So are there any questions about any of that? Yes?
Has characteristic a subquality of inheritance?
No, we would have to check exactly how the logic for that goes, but nothing inheres in a process for BFO, just as nothing is a quality of a process for BFO. So this particular picture here is correct. This particular picture here is not correct. So that is how it looks now. And has characteristic is a defined relation. So it's not a real relation. As BFO sees the world. Yep.
With respect to physical processes, will be wise to look at not only biological processes but other processes?
Oh, absolutely. So once we have this terminology, we can start looking at physics again. So we have a poor treatment of physics in BFO, and we now have a quite a strong desire to, in tandem with building the units of measure ontology, to expand our treatment of physical terms like mass and energy and momentum and force and so forth. Yep.
I was wondering about the systems. You were saying the material and material.
Yeah.
Why not generically dependent?
So we want the solar system to be a system. We want the Milan subway system to be a system. And we want the IBM system for making money by having you use their software for free but hire IBM consultants to be a system. Those are the three challenge examples. And all of those we see as being material entities.
What about system of differential equations?
Hmm?
What about system of equations?
I can't hear the word, there's an echo.
Equations?
System of equations is not a system. In our sense, you have to start somewhere. Todd?
Barry, do you have a proposed approach to dealing with units of measure yet?
We're at the stage of tinkering. So we haven't settled. I don't think there will be one general approach. I think it will be a multi-thronged or multi-threaded approach. Units of measure are so heterogeneous. We're going to have to crack different groups of them separately, I think. But as I say, we're still at the tinkering stage.
In your tinkering, are you considering the introduction of qualities as related to units of measure?
Some of them will be qualities, yes. Temperature probably will be a quality. I mean, degrees Celsius will probably be a quality, or a quality dimension. This is one area where we believe that Dolce is actually in better shape than BFO. And so we're going to draw some inspiration from Dolce.
Did I understand you to say that you're considering a unit of measure as a quality?
No. Temperature, I said, is a quality. And so degrees Celsius will be a quality dimension or something like that.
All right. Thank you.
Yep.
You said one of the requirements for top-level ontologies was to deal with mathematical entities. What's the current take of BFO as a...
So we have to have a way of dealing with mathematical entities, but that way doesn't have to be philosophically convincing. So our way of dealing with equations, for instance, is that they're information artifacts. We might have a better way when we've finished some of the work on physics, but at the moment equations are information artifacts, just as digits are information artifacts. Numerals are information artifacts. Yes?
Maybe related to that, so I think in the beginning there was a sense that you proved domain neutrality for BFO.
So we showed that we meet the requirement of domain neutrality. I wouldn't call it a proof.
But how do you show it? Who needs to be convinced? So is this part of the...
So I think this is one of those cases where you provide the documentation and then someone can inspect it. So I will give you the list of BFO classes with the definitions. You show me which one of those is domain specific. And so there are obviously going to be in the middle some borderline cases. Is space domain specific? Time? I guess the closest or the most problematic one would be function. Are there functions on other planets or in other galaxies? I'm just not sure. But we define function in a domain neutral way using terms like exist. So we think we're okay, but function would be in the penumbra, and we explicitly allow that there will be a penumbra of terms which are very general but perhaps not maximally general in any top-level ontology. Yep.
I also have a question that comes to methodology, which may be
Yeah.
Do you have constraints to relate the natural language description with the formalization?
Yeah. Yeah.
Which
So
is
the simplest constraint is that the signature of the natural language artifact has to be identical with the signature of the common logic artifact.
But then the description should match a bit of the formalization, right?
So yes, so the goal is that the content, this is an interesting problem, the content of the definitions should match the content of the common logic axiomatization. But you can't do that in a one-to-one way for all kinds of reasons. And so whether we have captured the content exactly is still an open question. Probably we will still have work to do in future revisions of this standard, but we've got pretty close, I believe. And you can judge for yourself, because I'm going to go through some of it in the next section. Yep.
Just to try and understand a little bit better, the has characteristic up there, is that just something to help align PATO, or is that something that would be a wider piece of BFO?
So the OBO foundry is an incredibly well-oiled machine. So you have a number of ontologies which are used on a daily basis by thousands of people throughout the world. And there is an OBO foundry central, which controls everything that they do. And so we made a decision. So this is not quite a true story, but it will give you an illustration. We made a decision to change PATO process qualities so that it would henceforth be called PATO process characteristics. Now, PATO process quality is a term used in hundreds of ontology initiatives around the world. By pressing a button, all of those occurrences in all of those ontologies were changed from process quality to process characteristic. It was a kind of miracle. And so that's what we have now. Now that, as I say, it's not quite a true story, but I witnessed something happen which was exactly as I just explained. The question is what happened a week later, which is a bit more complicated.
The other question is, I noticed one of your challenges was to deal with frames of reference.
Yes.
For spatial
Yeah.
entities in particular.
Yeah.
So are frames of reference information objects of kinds that apply to concrete things, or are they somehow part of the concrete world in space, physical space that you're dealing with?
So if Alan were here, he would be able to say something intelligent in response to that question. I am tempted to start working on frames of reference and to assume that they are information artifacts. And then as soon as we realize the limits of that approach, then we can move over to do real physics. Alan wants to do real physics already at the very beginning. But Alan has been wanting to do real physics at the very beginning for years. And he still hasn't got a good definition of frame of reference.
Well, I'm struggling with that too, to some degree.
So we would be very interested in contributions from you on frames of reference.
I'm not sure I have any right now, too.
It's a hard topic.
Well, I mean, something like a coordinate reference system
Yeah.
for space.
Yeah, but if you define it as being like a coordinate reference system, then you're ending up with being an information artifact.
Yes. Exactly.
And that's not quite what a frame of reference needs to do if you're going to deal with relativity theory, which is what Alan wants to do.
I'm not sure.
Yeah. If it wasn't for Alan, we'd all be done. But Alan insists that we are physics compatible, and that is difficult.
I'm still not sure why you can't treat it as an information artifact, but that's a long
Because well, yeah, that's a long story. That's a long story. A philosophical story, which we don't have time for.